We're now going to talk about the structure and functionality of the Primality Microservice. This is going to be very quick because this should be review. We've talked about stuff like this before. This one uses the virtual thread per task executor concurrency model. And it's got a controller with a REST control annotation. It's auto-wired to the service. It's got a method called check primalities. It takes a list of integer prime candidates and forwards it to the service. It's got a get annotation with this route name, and it uses request param so it can deal with the list properly. That's all review. The internals are kind of fun. In this case, we're going to make it a service, and we're going to take that list of integers that are passed in, the prime candidates, and we're going to create a new virtual thread per task executor using the try with the resources block. And then we're going to go ahead and call get futures from the prime candidates and the executor we just created. And that's going to return essentially a list of futures to prime results, because remember, we're using the Java 19 syntax. And then we're going to convert that back into a list. So let's go ahead and take a look at the source code where it becomes more clear what we're doing. So let's talk about how to implement the Primality Microservice, which uses the virtual thread per task executor model, and you can get it here in the ES3 project in WebMVC folder in the Live Lessons GitHub repository. Here we are back in the project. The application is the same as before, it just works with the Primality Microservice. The controller, nothing really interesting there. Let's go look at the Primality service. That's where there's a few more goodies to discuss. So as you can see, we use the try with the resources block, making ourselves a new virtual thread per task executor, and we make a call to the get futures helper method, and that will then do this. It takes the list of prime candidates, turns it into a stream of prime candidate integers, and then we call check primality for each of these prime candidates, passing in the prime candidate and the executor. So let's go look at that. And you can see what that does is this is actually a nice example of nested structured concurrency. So if you take a look back up here, we have this guy. So this is going to run in its own virtual thread. And then down here, this is going to call check primality, which runs in its own virtual thread. We didn't necessarily have to create a virtual thread for the other one, but what the heck, why not? So here you can see what we do is we take the prime candidate, and we're going to submit a task to run in this executor, and that will then go ahead and see if the number is prime or not, and it'll display the results when we get back here. And then we wrap this thing up in something called a prime result, and you might suspect by now that prime result is going to be a record, just like we use for the GCD microservice. So we have a record that takes the prime candidate, and then it returns the smallest factor, which is 0 if it's prime, otherwise it's the smallest factor. So that's what we do there. We use records again. We return a record. You can see check primality returns a future to a prime record because it's doing it through submit. And we come back up here, and we can see that we take what comes back here, which is a stream of futures to prime results, and then we collect them into a list. And so we end up with a list of futures that get returned here. And then the convert futures method does something very simple, similar to what is done for your assignment 1B, where we convert the list of futures of type T to a stream of futures of type T. We map them to the current results, which works fine because they're done. Otherwise, we wouldn't have gotten this far. And we turn that stream of T into a list of T, which in this case will be a list of the prime results. So that's what we give back. We give back a list of prime results. That also has a lot in common with some parts of your programming assignment. So that's basically the microservice for primality checking. Very straightforward, easy to use. I think you'll agree for simple things like this, where we just need to do an invoke all operation, where we want everything to run in parallel, the virtual thread per task executor works quite nicely. It doesn't have a lot of syntactic overhead.